about proofs. But CPCTC stands for corresponding parts of congruent triangles are congruent, meaning that if I can prove that two triangles have corresponding parts congruent, then every single part of the triangle is congruent. So if I'm talking about two different triangles, think to yourself, what are the different parts that I have of a triangle? So I have this angle, and a corresponding part would be the same value on the other side. And then I have the second angle, and I have my third angle. So we have three angles we can talk about, and we also have sides. So we have three different side lengths. So in total, there are 6 corresponding parts for triangles. All right, so if we know that triangles are congruent, we can say that all the corresponding angles and all the corresponding parts are congruent. So here I have an example where I have the two triangles. I state that they're congruent. That little symbol, again, remember, stands for congruent. Okay, and it states that triangle ABC is congruent to triangle DEF. So notice that the letters are matched by color. So A is in the first position, D is in the first position. B second position, E is in the second, C is third, F is third. So we can match also the letters to each other. So if I have triangle, let's say triangle cool is congruent to triangle book, then I can say, also obviously that wouldn't be book, but you get what I'm saying, that C is in the first position and B is in the first position. So C and B are the corresponding parts of that actual shape. So I have 3 different angles that I can set that are congruent, and I also have the side lengths that I can set that are congruent. Okay, so just kind of look over this diagram just to kind of see the different comparisons and how the blue letters match up with the blue letters, the green with the green, the purple with the purple. So it's all about the positioning of where it's actually talking about in the congruency statement. Okay, so here's an example. I have a triangle RST is congruent to triangle LMN. So R and S, so side length R and S, is going to be congruent to side length. R is first, S is second, so L is first, M is second. LN, L is first, N is third, so I need the first and the third letter, so that's going to be RT. Angle S is the second angle of the triangle, so that's going to be angle M because that's the second angle of the second triangle. TS, working a little bit backwards here, but that's congruent to NM. Angle L is congruent to angle R. Angle N is congruent to angle T. So just kind of check over that work to see the positioning and how I'm using the letters to guide me. Okay, so here's an example. I've got 2 congruent triangles. I can obviously see that the angles are where they're supposed to be. Like I can tell that G and K are look-alike because they're in the same orientation. But if a triangle were flipped, I'd have to rely more on the actual notation. So if I'm trying to find what X is, actually we're going to do KL first. If I'm trying to find KL, then I need to know that KL corresponds to GH. So KL and GH are the corresponding parts. But it looks like I need to solve for JK instead of KL first because I need to solve for the Y. So because those parts are congruent, by definition of congruence, that also means that the parts have an equal measure. So the length of the sides are equal. And I can just solve that just like how I would solve a regular 2-step equation. So 27 equals 3y, divide by 3, y is 9. So that means that KL is 9. Okay, for X, we're going to use the angles. If angles are congruent by definition, again, of congruence, that means that the measures are equal. The measures are equivalent. So I can take 4x minus 20 and set it equal to 108. So times 20, or plus 20, 4x equals 128, and that's going to be 32. And that's what I needed to solve. So it's just setting those corresponding parts congruent to each other. Okay, we have a different example here. So find the value of x. I have this triangle here. I know that this angle and this angle form a linear pair. Therefore, this angle has to be 90 degrees as well. So that means I can set 90 degrees equal to 2x minus 16. Add 16 over, that's going to be 106 equals 2x. Divide by 2, x equals 53. For finding the measure of D, it's not so obvious. I mean, it looks obvious, but we can't ever trust a picture. So we know that A and D are in the same position in the lettering. So A is first, D is first. So that means those two are the corresponding parts. So if A equals 49.3, then by that corresponding parts are congruent. That means angle D will also equal 49.3. All right, we have one more quick example. So I recommend that you pause the video here and just kind of look over the corresponding parts and try to solve. So pause your video. I'm just going to solve these real quick, and when you're ready to come back in, you can come back in and check for your measure of what x is. All right, you should have gotten x equal to 4. So hopefully you got that right and you're feeling awesome about moving forward. All right, so this leads us to triangle congruence theorems. There's 5 different theorems that you have to be able to know. So we have angle side angle theorem. So it's not necessary to prove that all 6 parts of a triangle are congruent. We don't have to say all 6. So these triangle congruence theorems can actually tell us that if we prove different parts in different orders, those have already been proven mathematically for us by some old mathematician guys. So the first one, angle side angle. So we have an angle and the included side between the angles. If those 2 angles and a side and their corresponding parts are congruent, that means the entire triangle is congruent. So we only needed angle side angle. And when you read it, you kind of read it like a book. You kind of like work your way, I say from the top, but I'm going to look at angle side angle, angle side angle. And you look at the matching letters as well. So you'll notice that the obtuse angle that we have, I don't know if you can actually see it, but it has 2 tick marks. That means that C is congruent to F. And B and E only have 1 tick mark. So B and E are congruent. So the number of tick marks can tell you how many which actual angles are congruent to each other. The next one is angle angle side. So the side that's included is not necessarily congruent, but if we have that one angle and then the next angle and a side is congruent and to the corresponding one on the other side, then we are also proving congruent triangles. So angle angle side. When I read it, I read angle angle side. I don't read it, so I'm going to say I don't read it as angle, and then I can't skip over this one and say angle, and then say like side here. So like when you're reading angle, angle, side, the next immediate angle has to be the one that's marked as congruent. All right, this one's the easiest one, side, side, side. If all 3 of the corresponding sides are congruent, you have a congruent triangle. So what I mean by congruent triangle, if I have 3 sides congruent, all the angles are also congruent. Next one is side, angle, side. So we have a side, the inside angle, and then the other side. The side, the inside angle, and the other side. So that makes it congruent. And the last one is called hypotenuse leg. So anytime you see a right angle, your brain should trigger to think hypotenuse leg. It's not always hypotenuse leg, but we have a leg of a triangle and the hypotenuse is always directly across from the right angle. So if we have the hypotenuse and the leg, that means the entire triangle and all its parts are congruent. So now I've got a lot of examples for you, and if you looked on It's Learning, you would have seen there is structured notes for you where I already printed off the examples, so I'd recommend you print those off and kind of take notes as you're going along. I know we're kind of already halfway through, but that's what I would have recommended, so you can see those examples and you don't have to write down every triangle. So we want to say, are they congruent? If they are congruent, then we're going to write down the congruent statement. What I mean by congruent statement is it's going to be like triangle ABC is congruent to triangle DEF. That is what a congruent statement is. So here I see that angle A is congruent to angle F. I see that side AB is congruent to side FD. And angle B is congruent to angle D. So you may be asking yourself, why did I do FD instead of DF? Because A has only 1 tick mark and E has only 1 tick mark. So I have to match up those letters accordingly. So for this one, I do have a congruent triangle. It's by angle side angle. and I have triangle A, B, C. We name a triangle by its vertexes of the triangle's angles, are congruent to F, D, E. All right, for this next one, this is an important little feature that you're going to come up to a lot. You see how this side is being shared. So that shared idea, that is called the reflexive property. So line XZ is actually looking at itself in the mirror. So that's the reflexive property. So anytime you see a line shared, I recommend like drawing a line through it, just kind of highlighting it and drawing an S because I know that the shared side exists. So this one is going to be angle side angle, and it's going to be triangle XZW is congruent to triangle ZXY. All right, so this next one, it gives me that I have sides that are congruent, so this side and this side are congruent because they have the same measure. Angle 12 is giving me that side length 12 is congruent to side length 12. And then again, I've got the shared side. So that shared side tells me that I'm going to have side, side, side. A little bit trickier here. One way that I kind of think about it is I say like, I kind of match the letters. Let me just try it. So I'm going to do an A, D, C. So A is in between the diagonal line and the 12. So between the diagonal and the 12 is C. I travel down the 12, so traveling down the 12 would get me to B, and then across the 5 to get me back to A. So sometimes the letters can be a little bit tricky when you're matching it up, but it is totally crucial in order to actually write that congruent statement. Okay, so in this case, we've got another special property coming up. So if you see those two arrows, that suggests that lines opposite are parallel. Whenever you have parallel lines, you should be thinking alternate interior angles. That's usually what's going to show. It's not every time, but alternate interior angles often show a lot. So you'll notice how the orange and the orange, so technically RQ is a transversal. So in this case, this is angle, side, angle. I'm going to skip over writing the congruency statement just because we have so many different examples, but I did post the key to this so you can see everything written out for you. All right, so this one I have another crucial type. I have vertical angles. So whenever I have vertical angles, I know that angles are congruent. So when I see these special properties come up, I label them, I highlight them. That way I can recognize that that's going to be needed, especially when I get to actual proofs. So this would be angle, angle, side. Okay, and then for this guy, again, this one's an easy one, angle, angle, side. All right, we have all three sides congruent. So that's obviously side, side, side. On both of these ones, all three sides congruent. So that's side, side, side. Now, something that can be kind of tricky is like, what if I gave you, instead of these two, what if I just gave you this one tick mark here? So I've got this one matching up with this one or potentially this one, but I don't necessarily have the 2 and the 3 that I'm looking for. So be careful when looking at the tick marks. Count how many tick marks you're looking at and see if they're matching to the corresponding parts. Okay, remember we said that we have a transversal, so we have that alternate interior angle thing going on. So alternating interior, and then I have the shared side, so angle, side, angle. This one is a really fun, tricky one. It says that M is the midpoint. So if M is the midpoint, that means that these two segments are going to be congruent. I also have, this side of the triangle is a square. So if this is a square and this is a square, that's also going to be congruent parts. Now we also have that the remaining part of it, this is a square. So like if this is X, and this is X, then this length here would be whatever minus X. This length here would be whatever minus X. These two actually are the same size by that idea that that's a square. So in this case, we also still have side, side, side. Okay, I'm looking at this one. I see an angle, angle, side. Hopefully you're starting to see the same idea. In this case, I only have 2 things given to me. So don't make up anything that doesn't exist. So this would, I'd just write not congruent. So anytime you have something that you don't think is congruent, you're writing not congruent. Okay, again, I've got vertical angles here, and in fact, I have 2 right angles. So it's more than just vertical angles. So as a result, I have a leg and a hypotenuse. So I have hypotenuse leg. Again, 2 right angles, I should be immediately thinking hypotenuse leg. But check this out. I kind of got tricky here. I gave something in the units of millimeters and something in the units of centimeters. And that's totally okay, because I can convert those and notice that those 2 are actually the same as well. And I have a shared side. That shared side is the hypotenuse. So that's hypotenuse leg. All right, what additional information is needed to require in order to prove that we have this congruency statement? So if we want angle, angle, side, I've got the vertical angles, so I need the non-included side angle, so I need this one and this one. That would give me angle, angle, side. So I need angle Y to be congruent to angle G. For angle, side, angle, again, I already know the vertical angle, so that's not the needed statement. Instead, I need C and T to be congruent. That means I have angle, side, angle. All right, and the last one, hypotenuse leg. So I've got the leg. I don't necessarily see the hypotenuse, so I need that hypotenuse to be congruent. Remember, the hypotenuse is always directly across from the right angle. So I need side length VU to be congruent to side length WD. Side, angle, side. I've got the side here. Side, side, and I've got the side here, so I'm missing the angle. So I need this angle. Now the tricky part here is it's not this angle that I need, it's actually this guy right here. Now whenever you actually have an angle that's shared by both, so if I just said angle X, am I talking about this one or am I talking about this one? So instead I'm going to name it with 3 letters. So I'm going to say angle NXW, X is the vertex of that angle, is congruent to angle VWX. All right, so just a couple angle congruency theorems. We're going to be practicing these a lot, but it is very important to make sure that you can identify them, because that's going to help you when we actually get to proofs.